Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is complex event processing using StreamInsight. Our guest speaker today is Mr. Rajesh Rangaswamy, Specialist Microsoft Platform at CEP Global Markets. Rajesh has over 13 years of experience in architecting, designing, and building enterprise-class scalable, distributed systems leveraging Microsoft technologies. He is working as a part of the Microsoft Technologies Capabilities Team, Sapient Global Markets, a division of Sapient. So without further delay, I introduce you all to our guest speaker, Mr. Rajesh. Over to you, Mr. Rajesh.
Thank you, Mohini. All right, I almost have an anxiety disorder waiting for that. Let's not wait or waste further. I'll move to the play. In the next 1 hour or so. First, let's start with
Rajesh, I would like to interrupt you. Your voice is not very clear. It's going up and down. Can you please check your network connections?
Can you hear me now?
No, there's breakage in your voice.
Okay, I am on my network. I don't know what else I can do. Do you want me to dial in?
Yeah.
Okay, I'll do that.
उसका प्लेटफॉर्म का अपने टेकिंग प्लेटफॉर्म पर
Mohini, can you hear me? Mohini?
Hello?
Mohini, can you hear me?
Yes, I can hear you now.
Can I go ahead with the same? I'm not able to dial in with the number.
Okay, your voice is fine now. It's clear. It's clear. You can continue.
Okay, thank you. All right, sorry for that. Let's revisit the agenda slide. The CEP introduction will form a primer to this webinar. This is a little important as most of us are a lot familiar with the traditional database-driven applications, but not that equally with event-driven apps. We shall get introduced to what an event is and a stream is then, and then we should also see the difference between a data stream or an event stream versus database-driven applications. Then we shall move on to what complex event processing is, and then take a look at some of the market, the products out in the market on CEP as such. As a next topic, we shall pick up StreamInsight and see how it fits in overall CEP picture. We shall also go about dissecting an existing StreamInsight application to understand the development model further. We will be looking at how input adapters, output adapters, event models, and how to fit them all. Finally, we shall take a look at some of the practical scenarios, and then we'll close on with some questions if possible. All right, let's move on. Let's move to CEP introduction as such. Let's see what an event is. An event is an occurrence within a particular system or domain. An occurrence means it's something that has happened or is contemplated to having happened in that domain. It's also used to mean a programming entity that represents such an occurrence in computing systems. Event contains only data and not operations, or you can call it as a value object or a POCO, a plain old C# object. Let's see what streams is now. A stream is made up of a sequence of events. It's ordered, as in there will be some kind of a chronological sequence applied on these events. It has temporal characteristics. What that means is the events within a stream are applicable only for a given time. In other words, they last only for a specific time. We also have homogeneous streams and heterogeneous streams. As the name suggests, the homogeneous streams is where the stream contains only a single type of event, or in a heterogeneous stream you could have multiple types of event. Example for a homogeneous stream could be a bell ringing, where a bell is the source of the event and the ring is actually the type of the event that's coming in. And for heterogeneous stream, you could say, let's say a CSV file reader source reading the CSV data and signaling that it has read the data. The event type could be based on the CSV schema, and hence it could be changing depending on the schema as such. Then let's see what event stream processing is. It's a set of technologies designed together to facilitate event-driven applications. Every event-driven application would want to perform operations on events or streams as they are received from the producers. Now, producers is a new terminology that we are introducing here. Event producers are components that generate events. These producers form the input sources for the next level processing. As part of the processing side, we would be, once you receive the event from the producer, you would want to do some kind of processing. The processing could be of detect, decide, and respond. To explain that, as an event is detected that it has happened in the event source, you decide what you want to do with the event and then respond. The response could be of forwarding the same event which has happened in the source, or it could be emitting a new event. So these events that are forwarded or emitted are actually consumed by a set of event consumers. These are the components in the pipeline that receives the events and act. As an example, let's think of a patient hooked up to a ECG sensor with the monitor above displaying his heart rhythm. The sensor could sense his heartbeat and send his measurements as they occur. Each heartbeat could be reported as an event. These events are then analyzed by an event processing system to indicate if the heart rate is normal, and that's when you hear a beep when when the heart rate goes below a threshold or above a threshold. Producers don't wait for responses. Think of a situation if the producer has to wait for a response. In a same ECG example, it would mean that for every heartbeat reported, the doctor has to acknowledge that he has received the event. That's not going to happen, right? So these events could happen at the rate of hundreds of thousands per second. Agreed that it could be minimal in ECG, but assume that there is consider an RFID sensor or an electricity meter ticking per every reading. Then this could be happening at the rate of hundreds of thousands per second, right? So the response would relate to the action taken by the consumer, and as the producer is not aware, or the producer need not be aware of what this is going to be. Another reason is that number of such consumers is often unknown at the time when the producer starts producing the events or even designed or coded. Let's move on to database versus data streams. Let's see how different a data stream is from a database. In my previous sessions that happen internally, I have seen people being confused between a database and a data stream. So I thought I'll elaborate that here slightly. let's see how different, in a database, the data is resting, right? That is like the data is resting in some tables which are pretty much serialized in the form of a file system. But in an event-driven application, the data keeps moving in a data stream. The data doesn't stop. The data or the event actually, keeps coming in, and there is no place it would be stopping, right? Or there is no place that it will be kept for further processing. The processing has to happen as the data or the event keeps moving. In a typical data-driven application, the application would be issuing queries that could be varying to a data that is resting in the database. So in your database application, your queries are actually ad hoc, or you would be supplying queries to a still data, whereas in your data stream, the queries are standing and continuous. Standing as in once you define the query will not change throughout the lifetime of the query instance, and the engine which is processing those queries has to be continuously monitoring the events as they appear. And finally, the data pattern in a database application is relational, whereas there are some temporal characteristics associated with the data. By temporal, what I mean is there are some time characteristics associated. I mean, as when the event is produced and what is the lifetime of this event. Is it valid for a given time, or is it valid at that point, and when is the end time of this particular event and all that. As an analogy, let's take these two examples. Let's take, a cycle parking lot. So a cycle parking lot would be like a database wherein the cycles which are parked are being data. And imagine a query which is being run like how many red cycles are parked in this particular parking lot. So the answer would be calculated as just go into the lot, start counting the number of red cycles. Now you could vary your query saying, how many cycles have butterfly handlebars. Then again, you would, get into the parking lot and start counting the, cycles with butterfly handlebars. So now imagine that, the same kind of, or a similar kind of querying has to happen in this, a cycle race. The queries could be how many cyclists have crossed point A, or how many cyclists are within, like 10 seconds within the leader, right? No, 10 seconds is a large number. So let's say how many cycles are within like 5 seconds within the leader. So you cannot, unlike this parking lot, right? So you cannot ask, the cyclists who are crossing point A to, stop, and then you cannot start counting. That's not going to happen. So what we would be doing is we would be positioning the observers at point A and ask him or her to start counting as the cycles cross that particular point. Now, consider the temporal characteristics. If someone has to count, then the cyclists which are within 5-second distance from from the leader at point A, then again you would push an observer who would be doing the job, and he has a specific task in mind, that is to count the number of cycles within 5 seconds from the leader at point A, right? So the analogy is that the data here is sorry, I'm getting something interesting. All right, sorry about that. Your data here, or the events that are happening here, are the cycles that are moving continuously, and the queries are actually standing, right? So the observers are standing and then monitoring the cycles that are crossing, and there are some temporal characteristics associated as well. Let's move on to the next slide. So we have been seeing what events is and event stream processing is. Now let's see what complex events mean. A complex event as such doesn't happen on its own. A pattern of events over a time period could result in a complex event. It's an event that summarizes a set of other events. In other words, it's born out of a pattern that is applied on a set of other events. Based on the type of the event that happens, it could lead to a opportunity or threat. In the patient example that we saw some time before, any complex event that is detected could be indicating a threat, whereas let's take another example. In algorithmic trading, wherein you trade depending on some market watch data. You would employ complex events to see if there is an opportunity to continue your buying or selling. Moving on to complex event processing, it's pretty much similar to what we saw in event stream processing, ESP as in event stream processing. Think of it as a subset of, think of CEP as a subset of ESP. So steps would be the same or similar at least. So you would analyze the stream of events or multiple streams of events in real time. And then you would want to recognize particular sequences or patterns across these streams, and then you would want to, from these patterns infer a business significant event from the correlated events. The following figure shows a typical CEP architecture or CEP application. On your left side, we have the event sources that are responsible for sending the events. The sources could be pushing the events like tickers. So ticker could be literally pushing the events, whereas from databases you would be rather pulling the events. Once the event reaches here to this stage, the pre-processing stage, what happens is some amount of pre-processing is applied before it is handed over to the next level of pattern matching part of the CEP engine. So this pre-processing could be, every event source might have its own event format, and you cannot apply a pattern over, discrete sets of, event types. So this pre-processing would be required to kind of, connect to this particular event source and then convert the event source type from, from the event source type to a CEP engines or CEP engine specific format. So that you can apply some temporal characteristics, as part of your querying. The format may be so the CEP format may be as simple as a date timestamp and an event source indicator from where the event has arisen. And a payload, which is the actual the event that has appeared or occurred from this particular event source. Once the pre-processing is done, the events are then washed over these queries. And then the filtered events reaches the post-processing side. So these patterns or these queries are actually preset in the CEP application or in the CEP engine, so that as the events are washed over, the matching pattern is then forwarded to post-processing. The post-processing would be kind of a reverse of the pre-processing as such. In post-processing, the CEP specific data type would be converted to event target specific data type, and then there would be a connection happening. It could be again a pull or a push, which means that the application could actually expose the filtered data sets, filtered events as for pulling or pushing. Again, that the target applications that would want to get notified can either pull the events or get them pushed. Let's see how this pull and push works in in the subsequent slides. Now, let's go back to our patient example. That was a simple example with only a ECG monitor fixed. Now let's hook up some more sensors, assuming that a patient is critical enough. Let's say we'll connect a BP monitor and even a pulse checker, and each of these sensors would start its own event stream. So a BP monitor will keep continuously reporting the blood pressure. The pulse checker will continuously report the pulse, and the ECG will continuously report the heartbeat. Now, a physician or a doctor can configure the system on a patient basis, so that he or the nurse can be alerted if certain combination of these measurements are detected within a certain time period. Let's say the pulse goes below a threshold, and then the BP increases or decreases, or the heart rate decreases. Then you could set up a combination, and as these events happen, there is a central monitor that keeps observing this data within a certain time interval, and if the pattern is matched, then it raises an alarm. right? So this is a classic or probably a very simple or a naive example of a complex event processing system. So the complex event which arises thus from the combination of all these three events is actually a threat to the patient, but provides an opportunity to the doctor to save the patient's life. Right. All right. So let's take a look at some of the CEP products in the market. Note that they are not given in any particular order, nor does their presence here indicate their popularity. It's just that I have come across these CEPs or CEP products at some instance, and I've just decided to put them across. And all these excerpts that you see below each of these products is an excerpt from their own websites. I haven't written anything specifically there. So the first one listed there is StreamInsight. I think for obvious reasons, the webinar session is around that, so we shall be seeing that in a little more detail in the upcoming slides. Streambase is another popular CEP product from Sybase, and it has been around for quite a long time. Now that Sybase has been acquired by SAP, it's now owned by SAP, I guess. Oracle's OEP, or Oracle's complex event processing, is another CEP product. It's developed as Java app server. Esper is another interesting product. It's open source based on Java, and as the tradition goes, there is a .NET equivalent of Esper, rightly prefixed with N, and it's called Nesper. TIPCO is in the market too with its own CEP called business events. There are a few more, but let's stop this now. I wanted to list these to show that something is common, and so you can see that the powerful and high throughput, and here it's high performance, and then real-time streaming, and on Oracle, if you see to filter, correlate, and process, and here in Nesper, if you see again filter, analyze events in various ways, real time, and then here it says opportunities and remediate threats. And sorry for that kind of bad highlighting, but yeah, that's it. So anyway, this is a classic summary of what a CEP is for. As we move on, you'll find that CEP products are for high volume, low latency, real time or near real time streaming. Near real-time stream processing with some pattern matching, and which really results in opportunities or threats. All right, so let's move on to what StreamInsight is about. Excuse me, just a minute. StreamInsight, obviously, is from Microsoft, is a platform for building complex event processing applications. The current version of StreamInsight is 2.1, released last month. But unlike any major, any minor version updates, this has a set of significant changes over 2.0, like the development model. We shall see that in the upcoming slides. It complements SQL Server. Only the license key is shared. No dependency exists between them. The libraries. What that means is, StreamInsight can run and exist without SQL Server, and SQL Server can run or exist without StreamInsight. It comes in two editions: standard and premium. As I said before, StreamInsight is used to build high throughput, low latency event-driven applications. Now, to look at what kind of event processing can happen, can StreamInsight provide. If you look at the standard edition, the recommended is less than 5. So this is recommended for less than 5,000 events per second with a latency tolerance of more than 5 seconds. What that means is, if a system is producing, or if your sources are producing less than 5,000 events per second, and if your targets, or if your business is okay with a latency tolerance of 5 seconds, then it can go for a standard edition. The premium edition goes much farther. It can cater up to more than 5,000 events per second. with a latency tolerance of less than 5 seconds. So we are looking at, thousands of events that's happening per second, and this is almost, if not real time, it's near real time at least. So it's in-memory processing, and it's continuous and incremental as well. StreamInsight processes the events in the memory, hence no serialization overheads, and I think that's how it's able to do that kind of, or it can go to that level of low latency tolerance, or low latency actually. Events are processed continuously and incrementally, thus analyzing the events using their temporal characteristics. It uses an adapter model and an IEnumerable observable model. Adapter model has been there for a long time, and IEnumerable observable had some limitations in the past, but I think that has also been removed. We shall be seeing that in as in the coming slides. Sorry. It's tightly integrated into .NET or Link. StreamInsight, says you can write the adapters of StreamInsight in .NET, and the queries or the patterns can be written in Link. It has two deployment models. One is you can run StreamInsight as a hosted or embedded server. The embedded deployment model allows applications to transparently embed the StreamInsight server into the solutions. If there is only one app instance that is working on a set of event sources, then this method is preferable. But if you have multiple applications that need to share the same event data sources and can benefit from access to multiple metadata objects, then you can always go for a remote server. For example, if you want to register one event source and run several patterns for that event source, then you can go for a remote model. Let's take a look at the StreamInsight architecture as such. The runtime components consist of a set of components to host the StreamInsight server. It contains the core engine DLLs for embedded hosting or a standalone service hosting. It also contains the adapter framework DLLs. There is a client-only installation available to connect to a remote StreamInsight service. That's if you go for a remote server mechanism, then there is a client-specific installation available which you can use and create your StreamInsight applications. So looking at this architecture, I think it's fairly close to what we saw 2 slides before as CEP architecture. So you have event generators on the left-hand side and event consumers on the right-hand side. So some of the event generators here are some devices, sensors, web servers, event stores. Some of them could use a pull model and some of them could use a push model. So points to note or points to recollect are the events in these event generators have its own structure. The number of, for example, they could have a set of fields and data types on its own, and they could differ from each source. And they may also have a temporal characteristic. For example, sensor could be generating event for a specific point. So that one particular event would be valid only at that instance, whereas a database could potentially say or report a transaction or any event that could exist for some amount of time. So that is called an interval event. Again, we'll be seeing that in a few slides later. So you can see that there is a set of sources here and there is a set of sinks here. So you might have guessed by now. So these are a set of specific adapters built for each of these generators, and this is what are going to do either the pre-processing or the post-processing. So every source will know how to connect to every event generator, whether it's a pull or a push, and then it will convert the source-specific data type to StreamInsight specific data type, and then it's then passed on to the standing processes or the query logic. These query logics are actually written in Link and made to run within the StreamInsight engine. And as the queries are watched over like this, the matching queries are then passed to the sinks. Sinks or the output adapters connect to the event consumers. Again, they know how to connect, either using a pull or a push. They have the connection information, which could be your a web URL or sorry, a web service URL, or a message bus address, target address, or it could be anything, or even a database for that matter. So again, the things will be changing the data type that is specific to StreamInsight to a consumer specific format, and then either do a pull or push. That's it. So let's move on to StreamInsight development model. StreamInsight applications, as you saw, as I was telling before, it can be developed using .NET. It supports framework 4. The current version is 2.1. StreamInsight uses both adapter model and the current, observable, IEnumerable model. In the adapter model, we have the input adapters, and so I think we have seen this enough. The input adapters or .NET libraries that can read events from event sources and convert to a CEP consumable format. So in this diagram, ET1 is your event source. E1 is an event that is coming out of this ET1, and it has its own type. A1 is a corresponding adapter for ET1, which reads E1 and converts it to a specific type. The color. They're all these events that is arising out of these adapters are of similar type, and the events that are occurring outside the adapter are of different type. And as these adapters convert the source specific format to CEP consumable format, there are a few query templates which has been defined at StreamInsight level. So these query templates are nothing but your link queries, and on the right hand side we have output adapters, so which has a similar task. I'll come to the query templates a little later. So we have CEP consumable or CEP specific format, or StreamInsight specific format, which is washed or passed to A3, which is the output adapter for A3. A3 is responsible for converting that to E3, which is of interest to A3. Right, so this is the event that will be consumed by the event consumer, which is E3. So coming back to the query templates, these query templates are part of the query logic. So the query logic consists of two parts. One is the query template, and other is the query instance. So this will be your query instance. A query instance is nothing but a runtime instance of a combination of your input adapter, your query template, and your output adapter. So one such pair combines to form one query instance that can be registered with StreamInsight engine. Sorry. As individual events arrive in the server, these events are processed by these standing queries, which emit output events in response to arrival of input events. I think we have seen query instances. Let's move on to the contemporary or the current model. The current model uses IEnumerable and IObservable. I guess most of us would be familiar on the IEnumerable model. So the IEnumerable, you can find it almost everywhere in .NET. So it's or in the collections, .NET collections. So it's used for pulling data. So you would be normally using a for each loop and iterating over these IEnumerable. So these IEnumerables are for pulling data, and there is another set of similar to IEnumerable, which is IObservable interface, which is used for pushing data. So if you guys are, if the audience is familiar with reactive extensions, they will know what this IObservable is. Anyway, at this moment we can just skip this, and in a later stage, probably on slide 13 or so, or 14 maybe, I'll be explaining them in a little more detail. So you can basically define, for example, if you want to go to the observable model, then you can define your event sources as observable, you can write your queries which are observing the observables or the event sources. Then your query results can be made as observables again, and your sinks or the output adapters, not adapters actually, because in the contemporary model they are called as sinks. They will be acting as observable for query results. So your sources or this will be actually a source which will be acting as an observable, reading events from this and exposing it as an observable. This query instance will keep observing this. So sorry, I'll draw here. The query instance will keep observing this as there is a new event coming in here. It gets pushed to the CEP server, which is again producing the query results. And these query results are again acting as observables to the sinks. Sorry, I'm drawing that everything in one diagram, but I think when we move on to further slides, I'll explain it a little more clearly. So let's start looking at how a typical StreamInsight app will look like. So to create a StreamInsight app, as a first step, you would have to analyze the business domain for the following criteria. You would define the situations to be detected first. These situations could lead to an opportunity or a threat, as we saw before. A situation will be defined as patterns in the CEP world or query templates in StreamInsight world. And then you define the information to be reported. This will be like what other information would be required apart from as part of your reporting of the opportunity or threat, or as part of your output event. What extra or what should be part of the output event as such to be reported, the complex event as in. If you look at the patient example, then this could be the life-threatening values from all sensors that has been detected. That can be argumented for the CEP event, which could be like patient is critical. Sorry. Then we identify and define the event sources. There could be multiple sources sharing similar or discrete data, which should be aggregating on. Each of them might send the event in their own format. So again, going back to the patient example, there are three different sensors, and each would be sending in their own type, and they'll have their own discrete set of data, which we should be aggregating on to determine if the patient is ill or not. Then you define the event target or the consumers of these complex events. Again, the factors that were applicable for event sources, such as event type, connection mechanism to connect and pull or push the data, is all applicable to the targets as well. And then you use the adapter model. So you analyze the temporal characteristics, and then you start creating an input adapter, or you start creating an output adapter, and then you write your query template using a link, and then all these, the input adapter, the output adapter, and the query template will be combined to form one CEP query instance, and then it's bound to a SQL, StreamInsight server. So once it is bound, you can just start the query. So you can start and stop the CEP query at will, and so please allow that. If you use the IObservable enumerable model instead of the adapter model, your event producer, on your event producer, you will implement an IObservable or enumerable for either push or pull, and then on the event consumers, you will implement the IObserver interface or a class that consumes an IEnumerable, and then bind these objects to queries. So let's take a look at how to write an input adapter. So an input adapter would read from source and enqueue to StreamInsight. So if you look here, excuse me. So points to note, so this particular input adapter is actually deriving from a typed point input adapter. This is the type we would be creating. And if you notice here, there is we use something called ZMQ subscribe socket. ZMQ is nothing but a 0MQ bus, similar to any other message bus, but for inter-process communications within your system, this is much faster and lighter. So this has been used for this illustration. So on receive from this particular socket, that is when a trade source or when an event source sends data to this particular subscriber, then this is the action that has to be taken. So you would be wondering where the actual connection happened. So on the start, so every adapter has a start method which will be called by your StreamInsight engine. So in the StreamInsight, we are subscribing to the address. So the address is coming from elsewhere. We'll discuss that in the next slide. So the address is coming as a parameter to it, and what happens is, we receive that event. If you notice here again, the event is received in its own type, which is a byte array, and then interpreted as a trade event type. And then we call a produce events, which is this. So this method takes the data from the on receive method, and what it does is it creates an insert event, and then puts the start date time, which is kind of a temporal data, and then keeps the payload as a trade event type. And what it does is it does an enqueue. So the enqueue actually pushes this data to StreamInsight engine. And now your adapters can be either typed or untyped. You can actually use a typed adapter if the event source only produces a single event type. That is, if it is with a typed adapter, the fields of the payload are known in advance. For example, in our case, we know how a trade event type would look like, so it's fairly easy. But in case the payload format is not known, then you could use an untyped adapter. So for example, if your event source is reading data from database tables, depending on the schema from which it's reading, the adapter could be untyped. Note that a single adapter instance at runtime can emit only one type, although it's untyped. So for example, if you bind one schema and if it starts generating one particular event type at the start, and it has to be the same until the end. Right. So in our case, the produce events is actually creating almost a similar event, but it may not be the case every time. Let's move on to how an output adapter would look like. Similar to input adapter, similar to enqueue function in input adapter, which pushes data into StreamInsight, we have a DQ API, which actually takes data away from StreamInsight, and it does a write to the target or strings. So this would be our DQ API. So this is where the DQ happens, and this is where the event from current StreamInsight will be placed, and then we convert that back to the format the event target would understand, and then we do a send right away. Again, the configuration to connect to this particular event target would be available through some mechanism, which again I'll be explaining in the next slide. So this is where so if you look at get CEP fields, what it does is it reads from SI specific format, and it just adds them as a list of strings so that it can be consumed by the target application. So the target application in this case does not understand the CEP type, but it does understand a list of strings, and so by ordinal position it gets to know what kind of data is coming in. Again, similar to input adapters, this can be typed or untyped as well. So if you look here, we saw a typed point input adapter in the previous slide, and this one has dropped the typed word, and this is actually a plain untyped point output adapter. Let's see how the event model is. There are 3 event models: point, interval, and edge. So excuse me, the point model means that the event occurs only at a single point of time, so it's instantaneous, whereas interval model means it's valid for a given period of time. We have an edge model as well. Edge events are similar to interval events, but kind of a special case. They are valid for a specific period of time, alright, but the difference between interval and edge event is that for an edge event, only the starting point of time is known. The ending point is actually calculated by or within the application. An example that comes to my mind is a web user session. Start of the user session happens when the request is received by the web server, but the end time is calculated based on certain heuristics within the web server. For example, was the session inactive for more than 20 minutes, then just close the session, or if the session is active only for or whatever, right? So so the end time is actually calculated by the server itself. For the above event models, you could actually build either a typed or untyped adapter. StreamInsight libraries provide the necessary base classes. So if you look here, we have for every event model, type, interval, edge, interval, or point, we have a set of input adapters and output adapters. And if you look at the nomenclature, it either uses a typed or it drops that word typed. So which means that it could be a typed adapter or it could be an untyped adapter. Excuse me. Then another important piece is the adapter factory classes. Now these are very important as it's the only way for your StreamInsight server runtime to create and dispose the adapters. So it's also used to pass parameters at runtime. So if you have noticed in the previous input and output adapter slides, we would be using some binding configuration info to connect to sources and targets, and that's actually passed through this. So if you look here, we are creating a new instance of trade event point input adapter, which is what we had in the previous slide, and we are passing a bus config, and we are passing some addresses. So this address, if you look at the config info, this is actually passed as part of the trade adapter factory as such. So when this particular factory is created, or when the create method is called by the StreamInsight engine, we could potentially pass this config info and the event shape. So based on the event shape, whether it's a point or an interval, you could decide which adapter to return. In this case, that has not been taken care. I think it's just returning a trade event point input adapter, whereas it should be like whether it's a point event, then return that particular adapter. Similarly, if you look at message bus output adapter factory, excuse me, so it uses the same or similar config info. So what it does is it creates a new message bus point output adapter and passes the config info here. So this config info is again passed when you bind it when you create this output adapter at the application level. Now that we have seen input adapters, output adapters, event models, and factories, let's pick them all. First, this is a simple console app written. So the first line says CEP server equal to server.create of StreamInsight v2. So this particular name, what we have given, is actually the one that we should be using when. So this is the name which has been registered on the machine when we install StreamInsight, and StreamInsight will be creating an instance of this particular. So we'll be looking for this name to see it's available, and it'll throw an exception. And the next line says the create application of trade events. An application actually is kind of a scoping unit. Think of it like a namespace, although it's not. But it's more like a scoping unit. All other entities that are created within this application, or that are created within this, are actually created within this trade events CEP app. So this is where we create the input adapter config. So this is where we set up the bus information, the address to which it's connected to. So this is where the event source is actually sending the information to. And if you notice, the next line says create a new CEP stream. It gives the name of the stream, the type of the adapter factory to use. Notice that we are not creating the adapter directly, but we are passing the factory here, and we are also passing the input adapter config along with the event shape. So these two information will be passed when when the create method is actually called on the trade adapter factory, and this is then inherently passed to the adapter, and this is the only way you can pass the information, let's say from config file or from the application to the adapter. The adapter will not know that in the design time, and hence this becomes important. The next query is actually a very simple query. Excuse me. So this is a query template. It's not really a query instance, but as the name suggests, it's just a query template. So what it does is it selects all the events in this input stream. So this input stream is nothing but every event that is coming in from the event source, right? So as the events gets published from the event source, every event comes here and then sits on this, or so there is no pattern really, right? But in real world, this won't be the scenario. So you would rather be using a query like this or a query template like this, wherein you're checking for where for each event, if the volume is greater than 1000 and if the price is less than 100, then select it and report it. So that could be one pattern that you would want to use. Or you could use a slightly complex pattern which says group these events based on on a window. So what it does is it actually creates a window. So every 5 seconds it groups them. So let's say if there are like 10 or 15 events that are coming within 5 seconds, all that are actually grouped underneath, and then there is a new group created, and sum of all the prices is calculated. What that means is every trade that's happening within these 5 seconds, calculate the sum of the price, and that is grouped on trade type. So it's like every trade type. Calculate the sum of the trades per trade type within 5 seconds. So we have tumbling window. So this is a simple window which groups the events every 5 seconds. And if you notice here, there is also a grouping function applied. So you could actually write some aggregate functions which can deal with the group data and then respond back to you on what you want to really do with that. So these are some examples of the patterns, but for brevity and simplicity, I have not used that. We'll go back to our illustration. And next, so after defining your input adapter and your so this is where you configure the input adapter. This is where you configure the template, and this is where we'll be saying how our message was config is. Again, this is config information, and then what we do is we bind them all to a query. So we take this template, create a query instance, which is this, and then we tell the StreamInsight server under which scope it has to be created, which is your trade event CEP app, and you specify the output adapter factory. So the input adapter factory is actually a chain here. I mean, if you notice here, input stream is what is your query template is, right? So now since you are using this here, the input adapter has also already been chained. So finally what it is required is we have to configure the output adapter factory, which is what is done here, and then the config info of the event target is set here. So this is where all the matched events will be going in, and this is just the event shape and the stream event order. So again, similar to input adapter, so similar to creating input adapter using a factory. If you notice here, even the output adapter is created using a factory, and the config is actually passed from this application through the factory. And all we have to do is do a dot start of the query, and StreamInsight will call the create method of this factory, pass this value, and then start listening to it, and then start running this pattern on that events which are received from the event, from the input adapter. Apply this pattern, and then as the patterns match, it will move it to the message bus output adapter. And here, as I said, there is no pattern. So what that means is, it will be reporting all the events as they happen. So this is using the adapter model. Let's see. I don't really have. I mean, I just quickly created this. So let's see how an observable or enumerable model looks like. So if you notice here. we have an observable trade event source, which is implementing the IObservable. Excuse me. Just need some water. So we have seen IEnumerable enough. It's Microsoft's implementation of the iterator pattern. So in the world of interactive programming, the app actively pulls the data source by pulling the data using IEnumerable. So you might have used a for each within your collection to get or pull the data. But IObservable is a case of reactive programming, and so that's when I mentioned the reactive extensions available for .NET. Here, what the app does is the app does a subscribe call to the data stream by calling the observable sequence, and from then on it just reacts. So the app doesn't really go and do a for each, but it just reacts to what it has been subscribed for. There are two interfaces that are required for the push model. One is the IObservable, and the second one is the observable. So the observer will be listening to the observable. So if you notice here, so the observer calls a subscribe method of this particular observable class, which is your observable trade event source. And all the trade event source, what it does is, it just does a subscriber.add, and as this observer is, as this instance receives even, it will be pushing to all these observers. It is a typical observer model or observer pattern. So some intricacies are, so now that the trade event source is actually created as an observable, it'll be interesting to note that the StreamInsight engine will act as your observer for this. So the query that you would have written will actually observe this. So StreamInsight would register as an observer, and then as the events happen, the data will get pushed from the observable to StreamInsight. StreamInsight gets those events and then applies it on their pattern, and then sends it makes the matched data available as observables again. So when it does that, there is an observing sync, which is an observer now. So this observing sync will actually act observe the StreamInsight. So if you notice the next example, so this is your main code where you create a new, so this is the line of interest. So you are actually, these two, I think we have seen this enough. So we actually create a new observable trade event source, and we create a point string, and then create an insert event from that point string, and we bind that as a query. And this is when actually this particular subscribe method is called. So what we have done is, forget this bed. So we are doing all trade events dot to observe, right? So this all trade events is nothing but your input stream, and input stream is nothing but your observable events source to dot point stream, right? So this creates, so this query actually creates observable, a point stream from this observable, and this is applied over this query, and then this query is made as an observable here, and then this is actually pushed to the sink. So the sink would actually subscribe to this. So you can see that the subscription is called on the observer. In this case, is a sink. So the events are passed from here to StreamInsight, and then from here it moves to the observing sink. The source or sink can be either an observable or an enumerable. So here the illustration is only on the observable. You can write a similar one for the enumerable as well. Now, together both these provide an alternative model for receiving data from sources to StreamInsight engine, or from StreamInsight engine to sink. You could use this model instead of adapters. In fact, so prior to 2.1, this model was only available for your hosted model and not for a remote instance. But starting 2.1, irrespective of whether your StreamInsight is a hosted model or a remote, instance, you should be able to use both these models interchangeably. Moving on, let's quickly see some of the practical scenarios. So these are some of the scenarios where CEP is applied heavily. Real-time risk monitoring is one such example. CEP has been long used in used in financial markets. To understand the exposure to risk in real terms, firms continuously monitor market conditions and try to manage risks across traders and per desk. And as the risks are surfaced with the patterns that is being employed, you could actually forward it to further workflows. Pre-trade compliance is another one. It's not long used, but there could be some possibilities of using CEP around this. As the trades are about to happen, you could intercept and monitor them and apply a set of compliance rules. Depending upon the compliance adherence or the absence of it, you could forward to further workflow or allow the trade to happen as such. Real-time web analytics is another interesting area where you can employ CEP. As scores of clicks happen in the website across the world, you could continuously analyze the user behavior of the website. You could also aggregate these behaviors across your web farm nodes, and all of these happen at real time. So you don't have to log these data and then analyze later. So think of this, right? So let's say if you're using Google and if you're doing a London Olympics, so Google does its own or shows the results on its own, and it also lists some links. Now you can employ clickstream analysis to say how many people are really clicking on Google's links, or how many people are going below that area and clicking on some other, or scrolling and then clicking on some other, let's say London2012.com site. And so, you could vary your data position, or you could vary your the results being shown by Google to wherever you would want to be shown. Smart power grids are other classics. I think we all know power grids. Smart power grids actually balance the load or based on the demand. So you could potentially gather the consumer behavior information as they happen. So imagine this, right? So events are generated from every electricity meter, and that gets aggregated at every subzone, zone, or region level. And as you gather this information and analyze the demand, so you could probably pull the supply from somewhere and pass it on here, or you could do some matching on the fly. And all this is real time, so there is no real, you cannot get the data, put it on a database and start analyzing it and then say, hey, the supply is more or required more there. By that time the demand would have gone, right? So it has to be near real time, or at least near real time. Algorithmic trading is another classic scenario. The patterns in financial market data are configured in the CEP engine, and automated trading happens based on specific match patterns. There are several other scenarios that I could think of, reporting exceptions, operational intelligence, and business process monitoring. In financial industries, again, a lot of fraud detection happens through CEP. In IT, as such, you could probably detect intrusions, network intrusions, and application SLAs, monitor application SLAs as they happen, or in high volume data, like RFID reading, or air traffic control is another classic example I can think of. Data coming from each flight near your airport, as they keep sending the information on how close or how far they are from the airport. This information has to be analyzed and seen if there are any two aircrafts that are coming dangerously close together. Again, it has to be real time, or at least near real time. By the time, I don't think we have enough time to push to serialize this data into database and start analyzing and then respond back. So that's not going to happen, at least. Moving on. Sorry. So some further resources for tickling the brains. Reactive extensions. This is again a Microsoft link for a better understanding of IObservable and IObserver. And then StreamInsight 2.1 documentation as such. We have some good amount of glossaries. I think it's very important for us to read the glossary section first. It introduces a lot of new terms which we are usually unaware as a as an application developer who have been doing a lot of database applications. And then the third bullet is a PDF, again from Microsoft, I believe. It's an awesome resource that explains the query model and the window timelines and even the event model for that matter. And it's really good. It's a very concise PDF with all and good amount of explanations. Lastly, StreamInsight 101 samples. It's a beginner's paradise, so anyone who's interested in learning StreamInsight has to start here. It has fantastic samples and some pre-built adapters as well, which you can configure right away and then start working. So that's it from my side. I'm open to questions.
Chat pane, Mr. Rajesh.
Sorry?
There are some questions in your chat pane. Can you please undock
Okay,
it and check the questions?
yeah, I'm just trying to see. Okay, so it's a little. All right, let me take some questions. I think some of them has been answered already in the press. So I will go through some interesting questions at least. What is the purpose of the patterns defined on CEP servers? And these patterns are nothing but your query templates. These are the patterns that you will be watching for. So I mean, without these patterns, you cannot react to any situations. So I think that has been again answered in one of the slides. Another question Sharad Nair has asked, and I think I'll still answer that. I could see a SQL Server database in your previous slide. Does that indicate some serialization? The answer is no. It's all in-memory processing. So the SQL Server was, indicated there to, say that it's. I guess it's part of, I mean, to indicate that it's part of, the SQL Server family, or, I mean, you could store some historical data for your query or pattern analysis. So I think that's the reason it has been displayed there. But yeah, I mean, that's a good feedback. What is the basic knowledge needed for StreamInsight application? I think you should be able to start with some basic .NET Framework 4. Apart from that, some of the further resources section will also give you a head start. And I think this PPT or this webinar also helped you at least in some way, I believe. Can input adapters be dynamic in reference to, I don't understand, but if you mean, I mean, how will these input adapters be created? These adapters will be created using the adapter factory that we have been seeing in the last 15 minutes or so. How do you see rules like rule engine and recent advance in says I'm sorry, I do not know that much of rules, but there is a lot of talks around integrating a rule-based engine with CEP or StreamInsight at least. So we have been doing some amount of proof of concepts in getting a rule engine fit into a CEP application. In fact, if you have noticed the complex query that I showed, it had a .isValid function. And that isValid function is actually in turn calling a rule engine, which loads the which has got a preset of rules and applies the rules on the the aggregated data as such. can we have an analogy for edge event model? I think we saw that, didn't we? So anyway, a session which is created in a web server would be a right example. So the start time is known when the user logs into the web server, but the end time is actually calculated at the server, and the user doesn't have any control over it. How is the monitoring and caching? Sorry. Okay. Is this architecture in the architecture? It's mentioned as VS 2010. Does it work only in VS 2010 or taken as example? To answer that, I think you can use. So I mean, I think so. The development model, it supports framework 4. I really haven't tried, creating in 3.5, and I don't think it supports. But I mean, I'm not sure. Maybe we'll have to check that. How is the monitoring and caching capabilities support of StreamInsight in comparison? I don't know what kind of caching capability that we are talking about here, but if you're looking at monitoring these queries, or how can I monitor these queries as they are run on StreamInsight, there is a management web service that is being offered as part of the StreamInsight package. It's a WSAVE service, and there is a management there's an event flow debugger also. It's a UI which you can use to connect to any of these services, which even in it works even in a hosted model. So you can see the events that are coming in and going out, and the patterns being matched as they happen. Will it support large files? I don't know how that matters, as long as your input adapter is churning out your events. It really processes them. I don't know if file is a concern for StreamInsight as such. It deals only with the events. So if your input adapter is capable of, or if your sources are capable of sending out that events, and it can handle up to, or with a premium edition, you should be able to handle even more than 5,000 events per second. Can you please comment on the stability of any of these CEP products, assuming that these server process should never crash? Well, so this is a question of longevity. To be honest with you, I really haven't gone that far, in really having it. But I guess you should be able to configure some failovers to make it running. So that I don't think that should be a problem. But as in terms of longevity as such, I haven't really tried running them more than a day at least. So yeah. All right, and so just scrolling along to see if there are any questions. I think I have answered most of them. Yeah, so we.
Thanks, Mr. Rajesh, for your session on complex event processing using StreamInsight. It was indeed a great session. I would also like to thank all our participants for their support and patience in making this webinar a success. The recording of this webinar will be available on techgeek.com by tomorrow. Thank you all. Have a great evening.
Thank you. Bye, everyone.